Hello students, good morning. I hope you all are safe and healthy at your home. In previous lecture, we started biomass as a energy source, and in this lecture we discuss about biomass advantages, disadvantages, and also we discuss about gasifier, classification of gasifier. Now in this lecture we studied about downdraft gasifier. Downdraft gasifier. Here also a schematic diagram of downdraft gasifier is shown. This is the downdraft gasifier. Typically, the gasifier is vertical cylindrical vessel of very cross section. You all are see cross sections of the gasifier in this figure. So, gasifier is a vertical cylindrical vessel of varying cross sections. The biomass is feed in at the top. You saw in figure the biomass is feed at the top at regular intervals of time and is converted through a series of process into producer gas and ash. It is noted that after completion of process we get two product. One is producer gas, that is the mixture of combustible gases and ash as it moves slowly through various zones of gasifiers. Different types of zones of gasifiers are described here. Number one is first zone, or it is also known as a drying zone because of drying takes place in this zone. Second is second zone or pyrolysis zone because here pyrolysis process is takes place. Next is oxidation zone where air trapped through nozzle at high pressure and temperature, that is oxidation zone because of in this zone oxidation process takes place. And last one is fourth zone, that is reductive zone. Here reduction unit process takes place. So in gasifier, downdraft gasifier, there are main four parts or compartment. First is drying zone, second is pyrolysis zone, third is oxidation zone, and last one is reduction zone. Now we discuss this one by one in detail. First of all, first zone. In I have different types of figure for downdraft gasifier. So in different figure is also described for different zone, but their mechanism is same in all figures. So we start with first zone. It is a drying zone in which the moisture content in the upper layer of the biomass is removed by evaporation. So here moisture is evaporated and our material, that is the biomass, is dried. Therefore it is a drying zone. The temperature in this zone is about 120 degrees Celsius. Very important 1 mark question is obtained here. What is the temperature of first zone of downdraft gasifier? Or what is the temperature of drying zone in downdraft gasifier? That is 120 degrees Celsius. Here in gasifier, this area contains 120 degrees Celsius. Here 120 degrees Celsius. This temperature is acquired by heat transfer from lower zones. That means pyrolysis, oxidation and reduction. Lower zones which are at much higher temperature. From this point, we know about that there are very high temperature in below zones, more than 120 degrees Celsius. Noted that in below zones, that is pyrolysis zone, oxidation zone and reduction zones have more than 120 degrees Celsius temperature. Now, second zone, the dried biomass moves down to the second zone called pyrolysis zone, which is at temperature ranging from 200 degrees Celsius to 600 degrees Celsius from top to bottom. I note out this zone. This zone is known as pyrolysis zone, and at this zone there is temperature ranging from 200 degrees Celsius to 600 degrees Celsius, top to bottom. Throughout this zone, the biomass loses its volatility. Biomass contains some volatile materials, and at that temperature, that means 200 to 600 degrees Celsius, the volatile material removes. Therefore, throughout this zone, the biomass loses its volatility. Continuing the second zone, in the lower part of this zone, when the temperature reaches 400 degrees Celsius, a self-sustaining exothermic reaction takes place. It is noted that self-sustaining exothermic reaction takes place in which the structure of biomass breaks down. At this temperature and exothermic reaction, the structure of biomass is breaks down. That is the main reason for breakings of biomass. That is exothermic reaction and temperature reaches 400 degrees Celsius. And then as a result, water vapor, methanol, acetic acid and significant amount of hydrocarbon tars are evolved. It is noted that after self-sustaining exothermic reaction and temperature reaches at 400 degrees Celsius, the biomass is converted into water vapor, methanol, acetic acid and hydrocarbon tars. The remaining solid is called char or carbon, charcoal or carbon. All the product, gaseous and solid, in this zone, pyrolysis zone, we get two state of product. That is one is gaseous and second is solid. So all the product gaseous and solid pass on to zone below. Now our third zone is oxidation zone. This is called oxidation zone. Air is passed into this zone through nozzles. Air is passed For oxidation process, oxygen gas, air is passed into this zone through nozzles and temperature ranging from 900 to 1200 degrees Celsius. This is the highest temperature in gasifier. At this zone, it is noted that very important point. In third zone or oxidation zone contains highest temperature. Temperature ranges between 900 to 1200 degrees Celsius. Combustion reaction takes place in this zone and a portion of the char and the pyrolyzed gases coming from the second zone are burnt. Here, second zone's gases are burnt. The principal reaction takes place are exothermic and oxidizing in nature, and product are carbon dioxide and vapor. Carbon dioxide and vapor are converted. So in this zone, oxidation zone, we pass air through nozzle and oxidize the second zones, that is the pyrolysis zones, the product. Now fourth zone, that is the last zone of gasifier. This product of combustion or oxidation pass into the fourth zone and last zone called the reduction zone. This zone is at temperature ranging from 900 to 600 degrees Celsius. Here temperature is down. In oxidation zone, here highest temperature 900 to 1000 1200 degrees Celsius. But in last zone there is only 900 to 600 degrees Celsius. The highest temperature being the oxidation zone. The main principal reaction are as follows. First of all, carbon dioxide is treated with carbon and carbon monoxide is obtained. This carbon is treated with water vapor, that is H2O, and converted into CO plus H2, carbon monoxide plus hydrogen gas, mixture of carbon monoxide and hydrogen gas. And in presence of more water vapor, carbon is converted into, in last zone, carbon dioxide and hydrogen. These reactions are endothermic. These reactions are endothermic. Please note that these reactions are endothermic and consequently the temperature are of the zone progressively decrease. It is also very important point. Temperature is decrease. The char is fully consumed and the final product are producer gas and ash. Final composition after completion of fourth zone reaction, we finally get gases in producer gas. The volumetric composition of biomass based producer gas is as follows. Carbon monoxide 20 to 20%. 20 to 20%. Methane 2 to 4%. Nitrogen 50 to 55%. Hydrogen 15 to 80%, and carbon dioxide 9 to 11. I repeat that carbon monoxide 20 to 22%, methane 2 to 4%, nitrogen 50 to 55%, hydrogen 15 to 80%, carbon dioxide 9 to 11%. And last point, conversion efficiency. It is defined as the ratio of heat content in the producer gas to heat content in the biomass supplied, and it is more than 1. It is more than 1. It is also very important point. The conversion efficiency is more than 1% in downdraft gasifier. Now the last point, application of gasifier. There are main two application. One is direct thermal application and one is indirect application. With the help of gasifier, we generate power. We get energy for motive power generator I discuss here. And then this power is used for electric power generation. Number 2, water pumping. Number 3, grinding. And number 4, other mechanical drive. Directly, the gasifier is used in chemical plants, in ceramic and pottery industry, in glass and process industry. And direct thermal application of gasifier is for cooking. We use these producer gases for cooking the food, for use in drying, for use in water heating, and for generating steam. This is the application of gasifier. Okay, thank you.